What's a robot? That is a great question, and you'll get as many different answers as the people you ask. To me, a robot is a machine that has some way of interacting with its environment and has some way of making at least some kinds of decisions on its own.
Most people will think about a robot as some sort of a machine doing tasks that humans might otherwise have to do, but now we can get a machine to do it.
There has been a tremendous amount of effort invested in trying to understand how the human brain works, and much of that has paid dividends in trying to build robots.
What isn't so well understood is how you actually make those things work in the real world. And that turns out to be a significant challenge.
What we're looking at here is the engineering model of the Mars rovers. This is a duplicate of what's on Mars. The MER mission was designed to go to Mars and study the past history of water on the planet's surface. We have a lot of cameras on this vehicle. That's one of our main sensors to tell what's going on. We have 2 on the front here. We have 4 on the mast. Stereo vision is using 2 images, just like we have 2 eyes, to see the world in 2 different views. Each view is a little bit different, and we can measure the difference between it, and that tells us how far away everything is. The Mars rover, and actually almost all spacecraft, have some level of autonomy where they can make their own decisions. We tell it a goal, we tell it where we want it to go, and it's able to decide on its own the right path to take to get there. It can sense the ground when it's driving and feels if there's a change in the terrain, and see where there's a big rock or a big ditch and automatically steer itself away. Even if we didn't tell it how to do that, it's smart enough to detect that on its own.
We talk about robotics, and usually people will start talking about autonomy almost immediately. The ability to act in its environment without having a human off to the side, sort of telling it what to do, joysticking around.
LARGA is actually a program learning applied to ground robotics. Robots can learn, not in, at the moment, very sophisticated ways, but certainly at least in simple ways which are effective, rather like the way you train an animal. We start with the most basic sensors, and one of the most basic sensors is touch. We have this bumper at the front, so the robot can crash into things and detect the fact that it has crashed into something. We can literally say to the robot, explore the world, and when you bump into things, well, you learn that those things are bad. And through that process, the robot itself can learn what it can drive over, what it can't drive over. It's very easy to put yourself in the head of the robot. Why is it doing that? I think it's doing this. And you also get cranky. When it doesn't do what it's supposed to be doing, you say, why are you doing that? I mean, you talk to the robot. You say, yeah, clearly you shouldn't be doing that. I taught you that was the wrong thing to do. Okay, now I sound like a parent. Getting a robot to see has historically been one of the most difficult problems in robotics. People don't appreciate quite how difficult the vision problem is because we do it so naturally. A very large proportion of your brain is devoted to the problem of interpreting that torrent of information which is coming in.
We are very, very good at interpreting what we see. We can all identify a chair, and they don't have all a seat, a back, and 4 legs. A lot of chairs are very different, or if they're covered by a pile of coats, we can still recognize that it's a chair. But how are we defining that in our brain? How could we pass that definition along to a robot so that it always knows what's a chair?
We can teach a robot this is a rock. It understands what a rock looks like, and it can recognize a rock. And we can teach it that you can't drive over big rocks. The problem is that then you put some grass in front of the rock, and suddenly it's a different thing. The robot no longer recognizes it as a rock. Overcoming that challenge, it's been a long, long, hard road.